Okay, today we're going to learn about the types of chemical reactions. Please turn to page 5 in your packet. We will be taking notes and looking at examples. So in chemistry, there are 5 main types of chemical reactions, and these are like the 5 most common. Your job is to be able to identify which type of reaction is being given if it's one of the 5 listed. So let's start with the first one. The first one is called synthesis. Sometimes you'll hear it called combination as well. This is when we have 2 reactants and they combine to produce a single product. So when we say single product, what that means is that we only have one type of product. It's going to be a compound, but you're just going to have one thing. Okay? So this right here is the general equation. So go ahead and write down this A plus B yields AB on page 5. Okay, notice how A is a reactant, B is a reactant. A lot of times these are both just single elements, or they could be a diatomic. They could even be a compound, but then what's happening is you've only got one single product right here. Okay, remember that anything to the left of this arrow is considered a reactant. Anything to the right of the arrow, you're dealing with a product. Sometimes products, depending on what type of reaction you have. Okay, but this is synthesis. So this is like anytime you're cooking or you're making something, lasagna, maybe it's cookies, maybe it's pumpkin pie, whatever it is, and you have all these ingredients, those are acting as your reactants, and then the final product is the pumpkin pie itself. That's a synthesis reaction. Okay, here's like a little fun little visual for you, Princess Leia and Han Solo, and when they get together and they are having a good day, okay, they can be the overall product. Okay, examples of this. Hydrogen and oxygen, those would be your reactants to create water. That's your product. And then another one is magnesium plus nitrogen, so again, your 2 reactants, and then you've got one product, the magnesium nitride. Okay, here's some little videos, so go ahead and pause the video and you can go ahead and watch that. Okay, the next one is called decomposition. Decomposition is just the opposite of synthesis. This is when you have a single reactant. So here, this is your the biggest clue is that you have one reactant. Again, it's going to be a compound, but you're only going to have one reactant, and it breaks up into 2 or more products. So an example of this, let's say that it's a hot August day. You just went to the grocery store and you bought cookie dough ice cream. Well, you ran inside the house and you left the cookie dough ice cream in the trunk of your car. You completely forgot about it for hours. You came back out realizing that you had to grab this cookie dough ice cream. And you're frantic driving to get home. The ice cream tips over in the trunk of your car. Well, now it's melted because it's several hours later, and now you've just got this pile of goo with gobs of cookie dough. So you can't eat it. So you decide, well, we're just going to have fun with it anyway. We're going to do something with it. We paid $5 for this ice cream. So you go ahead and you separate out the cookie dough, and then you get as much of the goo over as you can, and that would be like decomposition. So it started out as solid cookie dough ice cream. Heat got the better of the ice cream, melted it, and now you're just separating it out into the cookie dough chunks and the vanilla goo that's left. Okay, that's decomposition. All right, so here's a little picture of the general equation. So again, AB yields A plus B. So this time the single reactant is a compound, and it's breaking up into 2 different elements, or sometimes it's an element and a compound. Okay, here's a picture. So again, here's Han Solo with Princess Leia, and then sometimes they disagree, and so then they're by themselves, and that would be decomposition. Okay, here's some examples of decomposition reactions. This one's hydrogen peroxide, and it breaks into water and oxygen. So again, what you're looking for here is the fact that we had one product. Okay, that's all we had is one type of product. Another one is this copper Roman numeral 2 chloride, and that breaks down to chlorine and copper. So those are both examples of decomposition. Okay, here's some other videos right here for that. Okay, the third type is called single displacement. Sometimes we call it single replacement. So whether you have the the prefix of dis or re before placement, it means the same thing. Okay, this is when we have a single element and it reacts to take the place of one element in another compound. So this is what this one looks like. Okay, you're looking for a single element and then a compound, okay, on the reactant side. Okay, this is all on the reactant side. Okay, so here's the general equation. A plus BC yields AC plus B. So just to give you an idea, let's say that A is a metal. Okay, let's say that B is also a metal, but C is a nonmetal. Okay, whichever element is by itself, so in this case the A, it's going to replace whatever is similar to it in the compound. So since A is a metal, it's going to replace B. Okay, so over here what happens is you get A, which is your metal, but now it's replacing the B and it's bonding to the nonmetal C. And then the B is all by itself now on the product side. Okay, I have a horrible scenario, but let's say that you're on an outing with someone you care about and you have a third wheel. Well, this third wheel secretly likes the person you like, and their intention is pure evil. They're going to steal who you like away from you. And so unfortunately, in this case, by the end of the outing, that person has taken the person you like. So A has replaced you, you were B, and then C is the person that both of you want to have your attention drawn to. And so in this case, that happens, and you're the one that's B over here. Okay, very sad. All right. Okay, another way to look at this, I'm going to rewrite this for a second. Let's say that we have this scenario. We've got A plus BC, okay, so same reactants, but over here, it's going to bond differently. We have BA plus C. So in this case, let's say that A is the metal, B is the metal, and C is the nonmetal, just like last time, okay? And again, oh, just kidding, we're going to make A a nonmetal. Apologies, okay? So let's say in this scenario, A is the nonmetal, so what it's going to replace is the C, the other nonmetal, okay? So then over here, what we get is the B is still a metal, but the A and the C have swapped places. And then the C, of course, it's still a nonmetal, but the C is by itself. So it's just right here, the only difference between these two general equations is that in this equation up here, the A was a metal, and in this equation down here, A was a nonmetal. Right there, a nonmetal. Okay, so again, the one that's alone is going to replace whatever's similar in the compound. So nonmetal replaces a nonmetal, a metal replaces a metal. Okay, here's a little picture here. So this one we have Han Solo, and we've got, Princess Leia, and then we've got Luke. Okay, something happens, Princess Leia gets mad at Han Solo, and so then in this scenario, these two, Luke and Han Solo, have switched places. So here's Luke with Princess Leia, and then Han Solo is by himself, which we know in Star Wars happens more than we'd like to admit. Okay, these are some examples of single displacement reactions. Notice that we've got one single element, and then we've got a compound, and then they switch places. So because magnesium is the metal and copper is the metal, these two switch places. So over here you get magnesium and sulfate, and then the copper is by itself. And here's another example. In this case, zinc is a metal, it has a positive charge. In this scenario, hydrogen has a positive charge, the chloride has a negative charge. So the two positive charged elements are going to switch places. So hydrogen's by itself, and the zinc bonds to the chlorine. All right, and here's some fun little reactions that show you an example of a single replacement reaction. Okay. The fourth one is called double displacement, or you've guessed it, double replacement. So in this one, we have two compounds on the reactant side and two compounds on the product side. And what happens is that ions are exchanged and we get two new compounds. So here's what this looks like. Okay, so in this scenario, let's say we've got a positive charge, negative charge, positive charge, negative charge. So again, like things are going to switch places. So A and C are going to switch places. And because these are metals, because they have a positive charge, metals always come first on your product side. So you've got the A, and now it's bonded with the D. And then the C is positive, and it's now bonded with the B. Okay, my horrible scenario for this one, and maybe it's not horrible, but let's say that you're on a double date, and you guys decide halfway during the date to switch dates. And so if that were to happen, that would be like a double replacement or a double displacement reaction. Okay, I have a really funny story. I have this man who's in his 90s now. His name's Lloyd, and he was my neighbor for a long time. Well, he had a twin brother, and they were identical twins. And they used to go on dates. And what they would do is halfway on the date, like they would be double dating, they would go into the restroom and they would change their shirt. And then they'd come back out and they would sit with the other brother's dates. And he would just laugh because he said it was so fun to be able to kiss two people in one night. And their dates like never knew that they did this. They did it quite often apparently, where they would switch dates for half the evening. So he thought that was pretty funny. Okay, so here's this example right here. We've got Han Solo with Princess Leia. Okay, let's say he's the positive charge. Princess Leia is the negative. Luke's positively charged. Chewie is negative. And they're going to switch places. So over here we get Luke is positive with Princess Leia who's negative. Han Solo is positive with Chewie who has that negative charge. So again, double replacement. Okay, here are some examples here. Okay, again, you can kind of break this apart and look. This one has like a +2. This has a -2, +2, -2. Oh, that's so nice. So this magnesium and calcium are both metals. They're going to change places. And right now I'm just showing you what their charges are on the periodic table. Okay, another example is down here. So again, on this one, positive. Okay, these two positives, the sodium and the hydrogen would change places. So now we get sodium and chlorine, and then the hydrogen and the sulfur that are bonded together. Okay, and again, there's a video, so you can pause and watch that. Okay, the last type of reaction is called combustion. Oh, but before we do that, here's just a little preview really fast. See if you can identify what these are. So look at this, decide is a synthesis, decomposition, single or double replacement, and then pause the video and come back. Okay, so on this one, because you have one single product, this is going to be your synthesis. Okay, do the second, third, and fourth one. Go ahead and pause the video, and then let's come back. Okay, the second one, we've got one compound and one reactant. And notice how the B and the C have switched places over here. So this is going to be a single replacement reaction. The third one, we've got one reactant, and it breaks into two or more products. So this one is decomposition. On this one, you've got two compounds. This is my abbreviation for compounds. On the product side, you also have two compounds. So this one is double displacement. Double displacement. I'm just abbreviating. Okay, I hope that helps. Okay. We're going to do the last one on a different video, but the last one is called combustion, and I will have a second video with that. Thank you so much. I hope that helps.